Hello, everyone. Welcome back to another week of conceptual physics. This week, I was missing some of the videos from my previous classes that I would usually share with you guys. So you're going to get a few new videos where I'm going to go through some of the things in your textbook that I would usually do. But this time it'll be mixed in with the examples as well. So everything will kind of be together. And so we're going to discuss the first 5 sections of chapter 8, starting with Ernest Rutherford and his model of the atom. So early models of the atom began before uh, J.J. Thomson, but he's credited with one of the earliest models. And his plum pudding model was essentially just a pudding of positive particles with electrons just randomly scattered throughout as raisins in the pudding. Well, as many of you probably know, and this was a dated representation uh, when I was young because I had never heard of what plum pudding was. So I'm sure you haven't either. But the idea is just that it was a mesh of positive and negative charges. The only difference between what Thomson did from others was the electrons were individual things. And based on, and even though his model of the atom was a bit primitive, right, it changed pretty quickly after his ideas. He's still credited with discovering the electron based on some of the other work that he had completed. After Thomson's model came Ernest Rutherford. And Rutherford attempted to probe further into what the inside of the atom actually looked like. And the plum pudding model didn't really make a lot of sense with the way that things interacted and things that occurred. And so Rutherford was trying to figure out what's going on inside of an atom. Does it really look like that plum pudding? Right, so he used a concentrated beam of helium nuclei. Okay, these are called alpha particles. 2 protons and 2 neutrons. And he fired it at a thin metal foil. The metal was gold. And he found that almost all of those alpha particles, those big helium nuclei with 2 protons and 2 neutrons, a positive charge, larger than a single proton, almost all of them just went straight through the foil. Barely deflected at all. When they would actually interact and hit the foil or do something different than other just go straight through it, they would tend to bounce around and turn right back around and come back towards where the beam was coming from. And now it's not, of course, it's not perfect. So they go really in all directions. But it gets turned around. That alpha particle would get turned around. But only every once in a while. Most of the time, it would just go straight through that foil and just keep going in whatever direction it was going when it hit the foil. So there's only one way that Rutherford could really understand what was happening here. The idea was that the atom itself was just mostly empty space. There wasn't really anything there for the alpha particle to hit. It was just going right through. Nothing was happening to it. Most of those alpha particles passed right through because there was nothing in the way to stop them. The ones that did bounce back, that was because they struck a portion of the atom where there was a concentrated positive charge. They struck the nucleus, where the protons and the neutrons of that atom reside. And at that point, the positive charge of the alpha particle and the positive charge of the nucleus of the atom repelled one another. And it pushed the alpha particle back in the direction that it came. And so Rutherford found that most everything, right? So if these are let's say we can draw some atoms. Well, if we have atoms with a center, and there are alpha particles coming in towards the center, most of the ones that don't hit the center are going to pass right through. But every once in a while, that alpha particle will hit that center point and bounce off. And this is the nucleus. This is the thing that Rutherford found. The electromagnetic force repelled those protons, or the alpha particles, back towards the direction that they came. So from this, we could determine the structure of an atom more succinctly. We knew that the positive charges and the neutrons were now held together in this tiny little place in the nucleus. And the electrons just kind of orbited around them. Models of the atom became more advanced from what Rutherford did. But Rutherford's discovery of the nucleus became really important as well, because of things that we learned later about what happened inside of the nucleus. And that's what we're going to talk about for the rest of this week.